In this video, I work example 11 on page 6 of your section 5.2 lecture notes on logarithmic functions. In this example, we're going to rewrite the expression, this logarithmic expression, as a single logarithm. So we're given 4 times log x minus 1/3 times log x squared plus 1 plus 2 times log x minus 1. And we're going to write that logarithmic expression as a single logarithm. So another way of stating the instructions is we're going to condense this logarithmic expression as much as possible. Now you'll notice that on the log, there's no base given, right? It's just log x. And so this is notation for what is called the common logarithm. So whenever you see just log x, it's talking about log base 10 of x. So we're actually condensing a logarithmic expression in log base 10, also known as the common logarithm. Now, when condensing logarithmic expressions, I have found that applying the power rule first to the logarithmic expression, and then it doesn't really matter what you do next, the product rule or the quotient rule. So in this logarithmic expression, right, we got 4 times log x in the first term. This 4 can be brought inside the logarithm and made an exponent on the variable x, which I have done here. In the second term, we can ignore the minus sign for a moment. We have 1/3 times the common log of x squared plus 1. That 1/3 can be brought inside the logarithm and made an exponent on the binomial x squared plus 1, which I've done down here. Okay. Now I left the minus sign out in front of the log. And in the third term, right, we got 2 times the common log of x minus 1. And so this 2 can be brought inside the logarithm and made an exponent on the binomial x minus 1, which I have done here. Okay? So that's application of the power rule. Now, in condensing the logarithm, it doesn't matter whether you do quotient rule or power or product rule first, right? Just whatever's convenient for you, whatever you're comfortable with. And so the first 2 terms here, we have log x to the 4th minus log x squared plus 1 to the 1/3 power. And so we can apply the quotient rule to this difference in 2 logs and condense this difference into 1 logarithm. And over here, right, we have the rules of logarithms written out. And so here in yellow, right, we've got log base a of u minus log base a of v, right, the quotient rule is equal to log base a of u over v. So we can rewrite this difference in 2 logarithms as the log of x to the 4th over x squared plus 1 to the 1/3 power. So we can write this difference in 2 logs as the log of a quotient or a fraction. X to the 4th goes in the numerator, and x squared plus 1 to the 1/3 power goes in the denominator, and I have rewritten x squared plus 1 to the 1/3 power as the cube root of x squared plus cube root of x squared plus 1, right? Remember, anything raised to the 1/3 power means cube root. And then we have plus log x minus 1 squared out here on the end. Well, now we're down to the sum of 2 logs, and we can condense this sum of 2 logs into 1 log using the product rule. And the product rule in reverse says log base a of u plus log base a of v is equal to log base a of u times v, right? So we can take the sum and write it as the log of a product. And so that's what I've done over here. I've taken the log of this in parentheses plus the log of this and written it as a single log as this times this. And so when I multiply this in parentheses times x minus 1 squared, I get this in parentheses here. X to the fourth times x minus 1 squared over cube root of x squared plus 1. So this sum of these two logs simplifies to the log of this in parentheses. The log of x to the fourth times x minus 1 squared over the cube root of x squared plus 1. And so we had a sum and difference of 3 logs over here. And this sum and difference of 3 logs is equal to this single log, the log of this in parentheses. And that's called condensing.